My name's Mike Thompson, Managing Director of Claytech Pumps. I'm also the Chairman of the Rainwater Harvesting Committee, which is a subcommittee of Irrigation Australia. I'm going to talk about the third component of the rainwater harvesting design spec, which covers the part from the rainwater tank through to the house and garden. In this part I will cover the pumping component, the pumps. I'll cover the bypass device or switching device, and also touch on filtration and also backflow. But before we start into that, it's really important to go back to the original design of the rainwater harvesting system and look how it's put together from the roof through to the house and garden. This design is put together by 20 years of research headed by Professor Peter Coombs, and also best practice of industry. It's important to look at the whole design rather than look at each individual component, because each interferes or relates to both other parts of the chain. It's important that you consider the whole system because it provides a natural treatment train from the roof all the way to the house. Let's have a look at the house first of all and see where water is used. So from the pie chart we can see this is a typical house, that the garden uses approximately 50% of the water and the rest is used inside the house. So you can see that if we provide water back into the toilets and washing machine, then and we're using some water in the garden, we're covering a substantial amount of the water use of a house. So for the homeowner, what's the benefits of using rainwater? Healthier plants. Plants obviously get a lot of benefit from rainwater, and you can see plants grow so much better when they get a good downpour of rain compared to using mains water. The clothes are softer for the same reason, and we reduce the use of mains water into the house, which saves costs for the homeowner, and by reducing the stormwater effect, it improves the conditions of the local creeks and waterways. Now I'd like to talk about the pump and what the pump is used to the house. So a pump has, in a household situation, two requirements. It's got the need to pump water inside the house for the laundry and the toilet, which for that application is a low flow and a low pressure application, but it also is needed for for garden watering, which generally is a higher pressure and a higher flow rate application. So the pump has two roles in a typical house. So when we consider what the worst case scenario is, it's really in the garden. So typically when you're running your garden sprinkler or your garden hose, you're looking at what you're used to from the mains water supply. So the video we're going to show is showing typical pressure might be in a household of, in my house was 350 kPa, and then comparing it to the hose being used at 300 kPa, and then we use it at 250 kPa and 200 kPa. So as you can see, the pressure coming out of the handheld hose is actually being reduced, and therefore the plume that you get is being reduced. Now if you consider a typical mains water supply is somewhere between 300 and 500 kPa, and it does vary, it does get a lot higher, and in some cases it does get a lot lower. But typically that's a general mains water supply scenario. So we get used to seeing the water being supplied at that sort of pressure. So we have to consider when we provide a rainwater harvesting pumping system that we're actually meeting the customer's expectations of that higher pressure. So that's why we sort of recommend that a pump and the pressure, mains pressure, should be at least 300 kPa to give the homeowner that feeling that they're getting a mains water system which is similar to what they would have got in a normal house situation. When we look at the demand required for the things with inside a house, we look at the toilet, which needs approximately 5 litres a minute, the washing machine, which is possibly less than 12 litres a minute, the hot water system being less than 9 litres a minute, and the garden hose, garden sprinkler of about 15 litres a minute. So when we go about sizing a pump, we usually look at what typically you would use with when you're using your appliances. So typically you might be watering the garden, 15 litres a minute, and at the same time running a washing machine of say 10 litres a minute. So if you add those two flow rates together, you get 25 litres a minute, which you want to run at 300 kPa. So typically the pump that you need would be that sort of 250 litres a minute at 300 kPa. And that is probably the entry level smaller pump that is supplied on the market. In a more busy household where you've got more people in the household, then you may need obviously more flow rate and providing more things operating at the one time. Let's talk a bit more about the pump. A pump basically provides water inside the house or to the garden. The pump is controlled by a controller which is either integrated inside the pump or it sits as a standalone item on the top or around the pump. What that does is when you open the tap in the house, the pump will start automatically, and then when you close the tap in the house, the pump will stop. So it's a smart device sort of giving you an on-off sort of application. You can have two options of having a pump in a rainwater harvesting system. The first is the pump external to the tank, and the second is the pump inside the tank. The benefit of having the pump inside the tank is that it's surrounded by the water of the tank. So it's quiet, it's out of sight, and also the electrical leads and everything are out of contact of small children or dogs. The benefit of having a pump outside the tank is that it's easy to get to, easy for maintenance purposes, and usually lower cost. So when you're selecting a pump, it's really important to consider a few really essential things. The first is energy efficiency. So in a rainwater harvesting system, it's important to use the smallest pump that you can use for the application, because a smaller pump obviously will use less energy. An alternative to this is to actually use a variable speed pump. A variable speed pump operates by changing its speed depending on the demand. So if the demand is small, like in filling a toilet, the pump will start and only operate at a very slow speed. If you're using it for garden watering, which is a higher flow rate, the pump will go faster and deliver that required pressure and flow. It's been seen that this type of pump can reduce the energy demand in a house by 50%. Of the pump by 50%. The second thing to really consider is reliability. It's very important to buy a quality brand, a known brand, that has a reputation of being reliable. And as everyone knows, the less you pay, usually is less you get. The fourth is to ensure that they've got the correct material of construction. So the material that's in contact with the water should be of a material that doesn't corrode. So typically what we use is plastic or stainless steel. Cast iron is not recommended for that type of application because of its corrosion, and not recommended for inside of house use. Can be used for water gardening. The most common pump that's been used in the market is a centrifugal pump, and a centrifugal pump is used because it meets the demands of the lower flow inside the house but also meets the demands of the watering the garden. A peripheral turbine pump can be good for water gardening, but is not recommended for inside the house. The pump standards that are used for our rainwater harvesting pumps is the Australian New Zealand standard 60335.2.41, which is household and similar appliances, and it's a safety standard typically written around electrical approval. It has an equivalent international standard called IEC of the same number. Most pumps that are manufactured internationally have approval to that international standard and therefore comply with the Australian standard. No rainwater tap pump can obtain watermark because there is no applicable Australian standard or Australian technical standard that the watermark approval can be certified to. But most products in the market are approved to the Australian Drinking Water Standard, which is AS/NZS 4020. It's recommended that any pump that's used for supplying inside the house is approved to that standard.